Okay, here we are everybody. It's grade 9 integrated science and you've had a load of fun this week or last week working out your answers to the measurement test. Well, let's have a look at the solutions to that test today. Are you sitting comfortably? Let's begin. Okay, first of all, working out significant figures or significant digits in the values we've got shown. We start with our number here, 500. We can see that the first digit that's not 0 is this one here. It's a 5. So that's definitely significant. But then it's followed by 2 zeros. And if it's followed by 2 zeros, there's no indication anywhere that those are significant. In fact, we can just call those placeholders. If they weren't there, the number would just be 5. And 5 is a lot different to 500. So, we've got just one significant figure. Moving on, we've got 0.060. The first digit is a 0. That's never significant. The second digit is a 0. If it hasn't followed a non-zero digit, it's not significant either. So we've got our first significant digit here. Yep, that's significant because it's not 0. And that is then followed by a 0. So we've got a 0 that follows a non-zero digit, and they're following a decimal point, so they're both significant. We've got two significant figures. 670.29. Yep, well this one is significant because it's not 0. This one is significant because it's not 0. This one, well, it's a 0, so it could be significant or not. But it's followed by non-zero digits, which are always significant. So that makes all 5 of them significant. So we've got 5 significant figures. 3,700, very similar to the one over here. It's a whole number. It starts with 2 significant figures, but then is followed by just a couple of zeros which are there as placeholders. So we've only got 2 significant figures. Unless anybody tells us otherwise, we don't know whether these are significant or not. 431.0 has 1, 2, 3 significant figures, but then it's followed by a decimal point, which is then followed by a 0. So we've got a 0 following a decimal point, following a significant digit, so that also becomes significant. So in total we have 4 significant figures. 0.009, well, zeros which do not follow non-zero digits are never significant. So that's not, that is not, that is not, but this is our only significant figure. So we just have one significant figure. There you go. Now, we've got those same numbers, but we've been asked to write them in standard form, or scientific notation. 500. Remember, we need to take a digit which is written between 1 and 0. So our first number is 5. And because we only have one significant digit, one significant figure, we're going to leave it at that. We now need to multiply that by 10 raised to the power of an index? Well, we've placed our decimal point here, so if we follow 2 places to give us 500, we raise that to the power of 2. And remember, of course, if your number is bigger than 1, the index here always must be a positive number. It cannot be a negative number. So you can check your answers. 670.29. We have 5 significant figures as shown earlier. The number of that, which is between 1 and 0, we place the decimal point between the 6 and the 7, and then we multiply it by 10, and here's our decimal point. So we raise that to the power of 2. 3,000, sorry, let's move to this one, 431.0. 4 significant figures. Our decimal point needs to go here to make a number between 1 and 10, multiplied by 10 to the power of, and we're going to move our decimal point 2 places again to give us that. 4.310 times 10 to the power of 2. 0.060 is also given to just 2 significant figures. So we need to put a decimal point somewhere to make our number between 1 and 10. Here. So we have 6.0 multiplied by 10 to the power. Well, now we have a decimal value, a value smaller than 1. So we're going to have to move that 2 places to the left hand side, giving us -2. And remember, if your number is smaller than 1, the index here must always be negative. 3,700 just has those 2 significant figures. Our decimal point will need to go here to give us a number between 1 and 10. And we're going to then multiply that by 10 to the power of, here's our decimal point, 1, 2, 3. 0.009, just 1 significant figure. 9 is our number between 1 and 0. That's here. There's our decimal point. So 1, 2, 3. Back to the left hand side. So it's multiplied by 10 to the power of -3. How was that? That was fun, wasn't it? Now, let's move on to using apparatus to measure interesting bits of stuff. The temperature of a swimming pool. I'm sure we all know that we call that a thermometer when we use something to measure temperature of something. We certainly don't use the units of Fahrenheit unless perhaps you're on a weather television program or in the United States. We will use degrees Celsius or even Kelvin. Note, we don't call it degrees Kelvin, just Kelvin. The volume of a tomato. Well, the volume of a tomato is quite an irregular object, so the best way to measure its volume would be to place it into a container with water in it. We'd use a displacement can, but then you need to measure the volume of water displaced from that can with a measuring cylinder. And the units of volume, well, in everyday speak, people tend to call them milliliters, but a more appropriate unit, the SI unit we could use, would be better written as cubic centimeters. Volume of milk used in a banana bread recipe, well, we just use a measuring cylinder. I guess if you're in your kitchen you might use a measuring jug, so I think we'd allow that. And again, we'd use milliliters or cubic centimeters. Time taken for a runner to complete the 800-meter race, well, that might well be a stopwatch or a chronometer. If I was running that race, we might well use seconds to record our time. If it was Mr. Riley, perhaps hours, but hours are not a very good unit. We don't like to use hours or even minutes really when we record time in science, so seconds would be much better. The mass of a 10 peso coin, well, we'd use something called a mass balance. Try to get out of the habit of calling that a weighing scale. Mass balance is a much better term, and we use grams or even kilograms. And the thickness of a credit card, my goodness, I wish I had one of those. But anyway, the thickness of one of those, best measured using a pair of vernier calipers, which would give you an answer measured in millimeters, which you might even convert to centimeters, or if you really wanted, into meters. Well, that's the first 3 questions for you. Let's stop there for the moment and we'll come back later.